Dear students, I welcome all of you in the another session of traffic engineering and management. So you all know that we have been learning very important topic that is related with the rotary intersection part. So that is our current module in which we have been discussing various important elements related to the rotary intersection. Now, in the last session, we had learned that what are the various types of rotary intersections such as rail separated intersections. So the name of this module is design of intersection, and in the last module we learned that in the last session we learned that what are the various types of intersection and what are the important elements. Now in this session what we are going to cover is we are going to cover the important guidelines for selection of rotary intersection. See, these are very important criteria, and you must to have certain important knowledge about this thing. So stay attentive. Let us start. We are discussing about the guidelines for selection of or the guidelines for selecting rotary intersection. So we have learned in the last session that there are certain limitations, there are certain disadvantages due to which the rotaries are not suitable to every location. We cannot provide the rotary at each and every location. See, it is not feasible, it is not possible. So there are certain suitability criteria, certain guidelines that we need to follow. First is that rotaries are only suitable. Rotaries are suitable when the traffic entering from all the four approaches means from this approach, from this approach, from this approach and from this approach are relatively equal. It means approximately equal traffic must be there. Then the second criteria is this, that the total volume of about 3000 vehicles per hour can be considered as the upper limit case, and 500 vehicles per hour is considered as the lower limit case if you want to provide rotary intersection. So if you want to provide rotary intersection, the traffic should be in the range of 500 vehicles per hour to 3000 vehicles per hour. It is only beneficial when the proportion of right turn traffic is very high, means more than 30%. Then they are suitable only when there are more than four approaches or if there is no separate lane available for the right turn traffic. Then they are suitable for the if the geometry complex. So what we have learned first is that the traffic should be equal. Then what we have learned, the minimum criteria is 500 vehicle per hour and the maximum upper limit is 3000 vehicle per hour. Then we have learned that the right movement plays an important role. Means more than 30% traffic is of right movement, then the rotary can be provided. The road, the approaches should be more than 4 or 4 or equal to, and that should also not have any separate lane for right turn traffic. And in case of complex geometry, the rotary intersections are provided. So go through these lines once again. I'm giving you 5 seconds for that. Read the important content. Let me underline the important things for you. See, this statement, then this, then this, then this, and then this are the important criteria. Apart from all of this, there are certain other guidelines also that are the part of rotary design elements. So let us learn about that. Various design factors are also to be considered whenever it is about designing of rotary. That involves design speed, shape of the central island, radius of entry, radius at exit, radius of the central island, weaving length. We'll learn about weaving length. See, we have heard this particular term. in previous session also. So we'll learn about that. Then the width of the carriageway, width of the rotary carriageway, entry and exit angles, camber, super elevation capacity. So you are aware of all these elements. That what do you mean by design speed? That is the 98th percentile speed. We have learnt about the super elevation, then the camber, then the carriageway. So you are familiar with this element, but you are not familiar with the importance of this element in the context of providing route. So we'll learn this. See, this is one of the photo that I have provided over here. This is exit radius. This is entry radius. This is weaving length. Weaving length means when it is taking turn from here to here and the length or the width of this particular road is very less. So in case that is called as weaving length. This is called as splitter island because it is splitting the movement in the directions. This is called as inscribed circle radius from this point to this point, and this is called as the diameter of that particular thing. See, this is weaving width once again. This is called as circulation width because it is here. This is called as approach width. This is also called as approach width. This is also called as approach width. So these are the various kind of elements that you have to learn. All vehicles are required to reduce their speed at the rotary because we know that the design speed of the rotary will be very lower. See, you can come here at the speed of 90, but you cannot take your turn from here to here at the speed of 90. It is mandatory that you have to reduce your speed. So it is like that. The normal practice is to keep the design speed 30 to 40 kmph. 30 kmph for urban and 40 kmph for rural areas. Let us discuss about the radius at entry. This is called as radius at entry. Okay. The radius at entry is determined by the design speed. We have learned that in urban area that will be 30. If it is rural area that will be 40. Super elevation and coefficient of friction. It is safer if we neglect the super elevation and only take friction in the consideration because in case of rotary movement, circular movement, the super elevation can cause issues to the vehicle user. So this is all about radius at entry, that is it is determined with the help of design speed, super elevation and coefficient of friction, where the coefficient of friction should be emphasized and super elevation should be neglected. It is safer to neglect in order to reduce the accidents. See, the allowable radius of curve, you have learned this equation I guess, is v square by 127f, where the v stands for design speed in kmph. As it is capital V, it will be in kmph. And the f stands for frictional coefficient, that will be between 0.43 to 47. Don't mix these things with the highway geometric design elements. In highway geometric design, we used to take the value of f as 0.35 to 0.37. This is not about the highway geometric design. This is about the rotary. So we have to take the value of f as 0.43 to 0.47. So these are various IRC criteria that if the radius of entry of curve is 20 to 35 meter, then the design space should be 40 kmph. If the radius is 15 to 25 meter, then it should be 30 kmph. So it is like this. Got it? Then comes the thing about radius at exit. See, the exit radius should be higher than the radius of rotary island. It should be higher than the radius of rotary island. Why? So that it can favor high speed by the driver. The drivers can move out of the rotary zone with high speed. General practice is to keep the exit radius as 1.5 to 2 times of the entry radius. However, but The pedestrian movement is higher at the exit approach. If pedestrian movement is very higher at the exit, then it should be same as that of the entry in order to keep the movement of pedestrians alive. Then comes the radius at Central Island. The radius of Central Island is about 1.3 times that of the entry curve, and it is adequate for all the practical purposes. Then comes the angle of weaving or wearing angle. See, this is the definition. The definition is that the angle between the path of vehicle entering the rotary and that of the other vehicle leaving the rotary. The angle between the path of entering the vehicle in the rotary and leaving the vehicle at the rotary at the adjacent road is termed as veering angle. And in order to provide the smoother flow, it should be it should not be less than 12 degree. The veering operation includes merging and diverging can take place between the two channelizing islands. This is the definition of veering length, or this is also called as weaving length. See, stay focused. The veering operation including merging and diverging. Merging and diverging you already know because I have taught those things in the previous sessions. In the session of conflict, in the topic of conflict parts. See, the veering operation including merging and diverging take place between the two channelizing island of the adjacent intersecting lakes. And this length of rotary roadway is called as veering length. Means it would be like this. Let me make it easy for you to understand. So it would be like this. See, this is merging, this is diverging. What is being written over here that the operation, veering operation including merging and diverging can take place between the two channelizing island. See, this island to this island. Of the adjacent intersecting leg. This is one leg, this is second leg, intersecting leg. So the length of this particular stretch should be called as veering length. If the design speed is 40 kmph, then it should be minimum about 45 as far as IRC 65 is concerned. And if it is 30, then it should be approximate 30. So this was the first part of the guidelines. I hope you have gone through the concepts thoroughly. Thank you so much.